A more or less complete polarization of light is observed in many circumstances. The polarization of light, scattered by the atmosphere at 90 degrees to the Sun, is highly polarized. There is a slight polarization of the light reflected by the Moon. On the other hand, there is a strong polarization of the coronal K layer of the Sun, and a partial polarization of stars. The Sun's magnetic field is considered to act directly on electrons to cause light to polarize. In the case of stars, the polarization would result from the orientation of the sidereal metal dust by the magnetic field in the arms of the galaxy. The purpose of this video is to provide a unique explanation for these two polarizations, and to present the experiment performed to highlight a similar polarization, the second polarization of the coronal K layer of the Sun in the plane of the galaxy. The device used is essentially made of a diaphragm tube, equipped with a photomultiplier, fixed on an equatorial mount. The opening of the diaphragm tube is 2.5 minutes. Sky blue gives a maximum output voltage of the photomultiplier of 25 to 30 MV at 90 degrees from the direction of the Sun. The polarization level is over 80%. The slight rise of the curve results from the motion of the Earth. A first measurement of the signal given by the K layer was carried out on December 7, 1996. Then no measurements were possible before February 22, 1997. The curves obtained were corrected for a decrease in illumination inversely proportional to the square of the distance from the surface of the Sun. The average of the three measurements of December 14, 1996 clearly shows a frequency of 4 extinctions per 360 degrees revolution of the analyzer. The K layer of the Sun, therefore, has two directions of polarization, which have a deviation very significantly less than 90 degrees, according to the curve of the averages of the measurements. The measurement curve of February 22, 1997 shows the same extinction frequency, and the two directions are at approximately 70 degrees. The polarization of the Sun's K layer is well known and corresponds to its equatorial plane. However, this experiment made it possible to detect a second direction of polarization. This direction is approximately 70 degrees from the equatorial plane of the Sun. This is corresponding to the plane of the galaxy. The magnetic field of the galaxy is negligible compared to the Sun magnetic field, so that the second polarization of the K layer of the Sun cannot be linked to the magnetic field of the galaxy. The first question is how the polarization of the K layer in the plane of the galaxy could have another explanation than the polarization in the equatorial plane of the Sun. The second question is then, is it possible that the polarization of the K layer in the equatorial plane of the Sun would not be a result of the magnetic field of the Sun? What could be the common explanation? You could add to this the zonal distribution of the inclination of comets with respect to the equatorial plane of the Sun, and also the fact that stars in galaxies do not rotate according to Kepler's laws. You should think that something very strange is happening in the equatorial plane of the Sun, as well as in the main plane of the galaxy.